Hi there, welcome. Today another section about establish these identities. So let's start it and discover the some identities to prove. We have here cot x 10 square x and 1 minus 10x out of 1 part plus 10x. So let's start it for the first one here. So we have here cot x equal sine 2x out of 1 minus cos 2x. Before to start it, we have here some recommendation. Note that sine 2x equal to cosine x times sine x, and sine and cosine 2x equal cosine square x minus sine square x. And the last one is cot x equal cosine x out of sine x. So here we have three tools to solve this problem. Let's start by the right side. We have here sine 2x out of 1 minus cosine 2x equal, instead of write sine 2x, I write this formula equal 2 cosine x times sine x, and the next one 1 minus, without write cosine 2x, I open the bracket and write cosine square x minus sine square x. Okay, so here I delete the bracket. It will be 2 cosine x, the same thing in the numerator, but the denominator it changed cosine square x. We have before the bracket minus, so I change the sign here. It will be plus sine square x. So also we have here the famous formula of trigonometry, sine square x plus cosine square x equal 1. So I move this term in the right side, sine square x equal 1 minus cosine square x. So without write sine 1 minus cosine square x, I write sine square x. So here in the denominator 2 cosine x sine x, this quantity it will be sine square x plus sine square x. We have here 2 cosine x times sine x. I add this two term, 2 sine square x, and I simplify by 2 in the numerator and denominator. Also I simplify by this sign and the 2 sine here and the power 2. It will be cosine x out of, we have only one sine x. That's it. It equal 10 cot x. That what we need to prove in the first thing. So let's move for the next one. We have here 10 square equal 1 minus cosine 2x out of 1 plus cosine 2x also. I change this one here. We have some note also, cosine 2x equal cosine square x minus sine square x. Okay, so I started by the right side, 1 minus cosine 2x out of 1 plus cosine 2x equal, here we have 1 minus, open the bracket, and I put, instead of cosine 2x, I write cosine square x minus sine square x. Okay? 1 plus, also, instead of write cosine 2x, I write cosine square x minus sine square x. So I delete the I write without the bracket here. I simplify the expression more. 1 minus, be careful here, we have minus. Between the bracket it will be changed. Here we have cosine square x, but instead of minus it will be plus sine square x. In the denominator, no changes. 1 plus cosine square x minus sine square x. So here we have, instead of the famous relation, here we have sine or cosine square x plus sine square x equal 1. I get two things here. We have the first one, it will be sine square x equal 1 minus cosine square x, or the last, I use this one in the numerator, but this one, 1 minus sine square x equal cosine square x. So I continue to solve this expression. 1 minus cosine x square x equal sine square x plus sine square x, and 1, this term, 1, and minus cosine minus sine square x, I write cosine square x. This two term, I changed, it will be cosine square x, this one, plus cosine square x. So here we have this two term, 2 sine square x out of 2 cosine square x. I simplify here by 2 in the numerator and denominator. So we have here sine square x out of cosine square x. That's it. It will be our result, 10 square x. That's what I need to prove in our question. So guys, don't forget to subscribe to our channel to have more content. So let's move for the last thing. Here we have 1 minus 10x, okay, out of 1 plus 10x equal cosine x minus sine x out of cosine x plus sine x. In this case, I started by the left side. It is easily more than right side. So we have here, note that the expression of 10x equal sine x out of cosine x. So let's start by the left side. Here we have left side. So 1 minus 10x out of 1 plus 10x equal, I take the same 1 minus, but I change the expression of 10 sine x out of cosine x. The same thing here, we have 1 plus 10, I change sine x out of cosine x. So if we have two fraction like that, 1 plus b out c equal c plus b out c. Or if we have 1 minus n out b equal p minus n out b. Okay, I use this to think two things here in the numerator and the denominator. So here we have 1, I change by cosine, it will be cosine x minus sine x out of cosine x. Okay, you say 1, I change without, instead of 1, I change cosine x plus sine x out of cosine x. So another thing to give you like a review. So we have a out c, b out c equal a out b. Why? Because we have here a out c, b out c. We have the same here, equal a out c times c out b. So I simplify by cc equal a out b. This is the proof. Why? Why this? Why you have this result? Okay, the same thing here. We have cosine in the denominator and the cosine in the denominator. So we have the two fractions here. We have the first fraction, okay, and the second fraction here, okay, but we have cosine x and cosine x. I can simplify by cosine x in the first fraction and the second fraction. So the quantity, the last quantity, it will be cosine x minus sine x out of cosine x plus sine x. That's it. That's what I need to prove in the first thing here. Okay, so guys, thank you so much to joining me in this lesson. Keep learning, exploring. See you in the next lesson. Thank you so much. Bye.